Alrighty, people. Well, we're working on this chapter. Is anything up there? No, it isn't. So I got to put it up there. Boom. There we go. What we're working with is parallel lines. So I want you to write down some of this stuff. So I'm not giving you a vocab sheet this chapter. So I do want you to write down some definitions so that if you forget over the weekend what a certain word is, you can look at it. Parallel lines are coplanar lines that do not intersect. Coplanar lines that do not intersect. The parallel lines in this picture are going to be the orange ones. Coplanar lines are parallel lines that do not intersect. The next big super important word that you have to understand is transversal. A transversal is a line that intersects two or more lines. And your transversal will be the purple one. So the purple one's a transversal. It does the intersecting of the two parallel lines. So the coplanar lines do not intersect. They never cross each other. Okay? Parallel lines never cross. They're parallel. Like our ceiling tiles have some parallel lines. Our floor tiles have parallel lines. Okay? All right. So, looking at angle 1. How do you think in this picture it compares to angle 6? They look like they're approximately the same. Abby says the same, and she is correct. They're approximately the same. What about angle 3? How does it work with 1 and 6? Also the same. And what other one would be the same? 7 would be the same. Okay. Angle 4 is the same as what angles? 2, 5, and 8. Okay. Now, there's a relationship between angles 4 and 5 that have a special name. There's a relationship between angles 1 and 7 that has a special name. There's a relationship from angles 3 to 7 that have a special name. And there's a relationship of angles between 4 and 6 that all have a special name. So all of them have different names of their relationships, and you need to understand them all. So I'm going to go back and forth, up and down on this, so don't worry that I'm skipping over stuff. I'll get back to it. Okay? So the first relationship we're going to talk about is alternate interior angles. Alternate interior angles are angles which lie on opposite, important word there, opposite sides of the transversal and in between the parallel lines. Okay, alternate interior angles. Angles which will lie on the opposite sides of the transversal and in between the parallel lines. I'm going to grab some colors here, so don't freak out that I'm covering up your stuff. So our parallel lines will be in orange. and our transversal being purple. And notice how these two 120-degree angles that I'm talking about are on opposite sides of the purple line. They're alternate sides of the purple line. So alternate, opposite, alternate means the same thing. Interior means in between. They're in between the parallel lines. And when you have parallel lines, they're marked with an arrow like this. So it shows these are parallel. So parallel lines are marked with an arrow. These are in between, and they're on opposite sides of the transversal. Okay, that's alternate interior angles. Okay. The next angles that we'll talk about is corresponding angles. And those are angles in the same corresponding position in relation to the angles. Or into the intersections, excuse me. So angles in the same corresponding position in relation to the intersections. So this angle is to the upper left of that intersection point. This angle is to the upper left of the intersection point. So if they're both to the upper left of the intersection point, they're in the same corresponding positions. They're corresponding angles. This angle corresponds with this angle. This angle corresponds with this angle. And this angle corresponds with this angle. They're all in the same corresponding positions. Do you get corresponding? Okay. Now, if you get those two, then the next one is really easy. Okay. We had alternate interior angles. Now we're going to have alternate exterior angles. Angles on opposite sides of the transversal and outside the two parallel lines. So, the purple line is our transversal. This angle is to the left of it. This angle is to the right of it. And they're both to the outside of the parallel lines. So if they're to the outside of the parallel lines on opposite sides of the transversal, then they're alternate exterior angles. Okay? All right, one more main definition left. The last one is same side interior angles. Same side interior angles are basically angles on the same side of the transversal. And in between the parallel lines. So the two angles in this picture are in between the two orange lines, in between our parallel lines, and both to the right side of the purple line of our transversal. So they're in between and on the same side. So in between and on the same side interior angles. Now, when you deal with same side interior angles, what's 120 and 60 add up to? 180. They're going to always add up to 180. So they're going to be what? What word starts with an S that talks about adding up to 180? Supplementary. Same side interior angles are going to be supplementary. Same side interior angles are going to be supplementary. The other angles that we talked about are going to be congruent. So when we have alternate interior angles, they're going to be the same size. They're going to be congruent. I got to undo that. Boom. So alternate interior angles are going to be congruent. Corresponding angles are going to be congruent. They're going to be the same size as each other. And alternate exterior angles are going to be congruent. They're going to be the same size as each other. So the first three that I talked about are all congruent. The same side interior angles are going to be supplementary. All right, so let's look at this picture. Okay, the kid on the snowmobile made a track like this. So we have, we'll go like this. Two parallel lines and transversal. All right, so let's look at the corresponding angles. Angle 5 is corresponding to which angle? Angle 1. These are in the same corresponding position. Upper left of the intersection, upper left of the intersection. Angle 6 is corresponding to what angle? 2. Okay, lower left, lower left. Angle 3 is corresponding to what angle? 7. And angle 8 is corresponding to what? 4. Okay, those are corresponding angles. Okay, so now alternate exterior angles. To be an alternate exterior angle, you have to be to the outside of the parallel lines. So 5 and 3 are on the outsides of the lines and on alternate sides of the transversal. What's 8 alternate exterior with? 2. Very good. Then alternate interior angles have to be to the inside. So angle 1 is alternate interior with angle 7. And angle 6 is alternate interior with angle 4. Okay? So we're good with that. You got to know which are which. So let's look at the same side interior. Angle 1 is same side interior with angle what? 6. Angle 4 with 7. Very good. All right. Once you know one angle, you can figure out every other one of them. Okay? Because alternate interior Alternate exterior and corresponding are all what to each other? Congruent, equal in size. And then the other ones are supplementary. So let's say angle X here is 60 degrees. Whoa, now once I zoom way in, my marker gets really fat. So let's go with this. Let's say X is 60 degrees, okay? What would angle 1 be? 60 degrees. What would angle 2 be? 120 degrees. Because same side interiors are supplementary. They add up to 180. What would angle 3 be? 60 degrees, because these are alternate interior angles. Okay? What would angle 4 be? 120, because it's a linear pair with this 61 versus 60, or vertical angles with that one. What would angle 8 be? 126, 127, 60. See how the pattern goes, okay? So, if angle 3 is 55, we can figure out every other angle. What's angle 1? This is the hardest question that I'm going to ask you over the next 1 minute. What's angle 1? 125, right? So then once you have those two, it's cake. Because every obtuse angle is going to be 125. Every acute angle is going to be 55. So what's angle 5? What's angle 7? What's angle 8? What's angle 6? What's angle 4? What's angle 2? See? Said. And once you figure out that first one, it's cake after that. All right. So we talked about all that stuff. Now we're to this one. Okay, a proof. If you know that the same side interior angles is a postulate, that's something we don't need to prove. Okay? Same side interior angles add up to 180 no matter what when you have parallel lines. Okay? So we can prove that these two are congruent. If we know 1 and 3 are supplementary, we can prove 1 and 2 congruent. How can we do that? Well, we can make up a proof. Now, given that M is parallel N, so if I say M is parallel N, what is my reason for that? Given. You always know that if it's listed in the givens, you write given down. 1 and 3 are supplementary. Well, we just said something about this. Same side interior angles, that's a postulate. So we know that they are supplementary from the same side interior angles. Now, what does the word supplementary mean? Adds up to 180. So the definition of supplementary angles says as angles are supplementary, then they add up to 180. Now, I don't agree with this next one. They say something different than I would say. Angles 2 and 3 add up to 180. What types of angles are 2 and 3? They are a linear pair. So what I would say is the definition of a linear pair. For some reason, they said it was the angle addition postulate. You know, which, yeah, you can maybe say that, but this is a much better reason. Much better reason. Now, see how this was equal to 180. This was equal to 180. Since they're both equal to 180, they're equal to each other. That is a transitive property or substitution. So you could say transitive property, or if you said substitution, that is just fine. Because we're substituting 2 and 3 for that 180 in this. Okay? Now, how do we get from here to here? What do we do to each side of that equation? We subtracted the angle 3. So that's subtraction. And then if angles are equal, then they are congruent. If their measures are equal, then they're congruent. That's a definition of congruence, or a definition of congruent angles. Either way. Okay? So that would be a proof on it. Couple left, and then we'll get started. All right. So this line's parallel to this line's parallel to this line, and this line's parallel to this line. Okay? So I'll erase really quick. Now you're going to use my fatter markers so you can see which ones I'm talking about. Okay. So if this line is parallel to this line, and our transversal is this line. And I have a 68 right here and a 1 right here. Okay? How big is angle 1 if this is 68? Well, what types of angles are these two? If they're in between the parallel lines and they're both to the lower side of that transversal. Same side interior angle. As that Tucker said, they're supplementary. So if they're supplementary, how big is angle 1? How big is angle 1 if they're supplementary? 112. Now I'm going to look for angle 2. So what I'm going to do is erase this. And then now with angle 2, I'm going to talk about these two being my parallel lines. And this one being my transversal. Because you got to take the lines that you're dealing with that touch the angles, that make up the angles. Okay? So these are our parallel lines. This is our transversal. What do we know about 68 and 2? They're congruent because they're in the same what position? Corresponding position. They're corresponding angles. This is to the lower, straight underneath the intersection. This is to the straight underneath of the intersection. If they're both to the straight underneath of the intersection, they're in corresponding positions. They're corresponding angles, so they're congruent. So angle 2 is 68. Now, erase those. So now the parallel lines between 2 and 3 are this one and this one. And that transversal will be this one. So angle 3, how big is that? Well, 2 is right here, 3 is right here. They're in the same what position? Corresponding. Corresponding angles are supplementary or congruent? Congruent. So angle 3 is 68. Last one. Okay, we're going to find all the angles here. Okay. All right. Angle 1. How are we going to figure out what angle 1 is? Well, it forms a linear pair with 110, right? And Lindsay, what do linear pairs always add up to? 180. Because if one's 110, you can't add them to 90, can you? Nah. So, 110 plus what is 180? This is 70 right there. Okay. 115 and angle 2. They form a what, Caleb? Huh? 115 and 2. They're supplementary because they form a linear pair. So, if that's 115, what's left for angle 2? 65. 65 and 115 add up to 180. Okay? All right. Now, angle 2 is 65. Angle 3, 2 and 3 share what relationship, Abby? They're what types of angles, 2 and 3? Out of those 4 types, what are they? They are corresponding, exactly, because they're in the same corresponding position. From the intersection, this is to the right and above. From the intersection, right and above, they're in the same corresponding position. So if angle 2 is 65, Abby, what's angle 3? 65. 3 and 4. 3 and 4. Well, look, it's easier if we just go this way. These two are corresponding. So since those two are corresponding, Kara, what is angle 4? 115. 45 and 6 are what types of angles from last chapter, Curtis? Do you know that magic word? Starts with a V? No. All right. Mr. Highland, what types of angles are 45 and 6? Starts with a V. All right. What would you say, Shane? They are vertical angles. So 45 and 6 are vertical angles. How big is angle 6? Mr. Highland? 45. And then this angle and this angle are alternate what, Alex Walk? Alternate what, 6 and 5? Alternate interior angles. And we know that alternate interior angles are congruent, so angle 5 is 45. So you can start figuring out once you got parallel lines, what all kinds of angles are. We could figure out every single one of these missing angles. Okay? We could figure out every single one of them. Okay? We could even figure out this one over here and this one over here. Okay? Once you got a couple of them, you can go from that and then figure them all out. All right. So, your assignment